cool. So we're going to do two things. We're going to post a selfie to Twitter from my phone, and we're also going to do some noise-making thing. In that order. 3, 2, 1. Cheers! Woo! Awesome. Thank you so much. All right. Let's make some noise for ESLint. Yeah. Everyone's like, oh, I guess I'll cheer that library. Anyone here use TypeScript? Yeah. Woo! All right. Cool. All right. I forgot the hashtag. Oh, well. Cool. So hi, everyone. We're going to be talking about setting up ESLint and TypeScript for React. I realized in the shower this morning that I should have named this talk, Don't Fear the Linter. I regret a lot of things in life, but that's okay. We're going to get a bit of a slow start because I hear people coming in, and I think it would be cool if we just shouted at them to join us. So I'm thinking we should all shout the phrase, don't fear the linter, in like 3 seconds. 2, 1, don't fear the linter! Now they're confused and angry and going to come in. Awesome. Thank you. We need more lint rules. This is good. So I'm going to talk about 2 of our least favorite things today. First, I'm going to talk about this thing, the linter, the stuff that gives you the little squigglies in the editor that you all hate. And I'm going to talk about emotions, specifically fear, uncertainty, and doubt. Fear, I have red editor squigglies. Oh no, something's broken. Uncertainty, I don't know why it's angry at me, and I haven't read the docs to find out. And doubt, I know my code works. The linter is stupid and wrong. I'm just going to ignore it. No more of that. Don't FUD it up. Instead, we are going to do static analysis. Yes, static analysis. Love and confidence and appreciation for all this stuff. Are y'all ready for this? Woo! Kathleen's moving to the front row to heckle me. Okay, great. Static analysis. Why so squiggly? Static analysis is this term I keep using. You might have heard it. It is tooling that scrutinizes your code without running it, which is in contrast to dynamic analysis, tooling that scrutinizes the result of running your code. Dynamic analysis is like testing. On the one hand, you have little unit tests all the way up to big end-to-end tests. And static analysis also has a spectrum like that. On the one hand, the left, we have speedy tools, all the way up to the slower but more powerful tools on the right. The speedy tool you might be using is like a formatter. Anyone here use Prettier? Yeah? Is anyone here the creator of Prettier? Is he in the room? Never mind, not well. And then we can get all the way up to type checkers, like y'all already cheered for, TypeScript or Flow, if that's still around. And in the middle, we have the thing that I play with, linters, stuff that is a little faster than a type checker, but is not quite as fast as a formatter. So we're going to go in and explore the difference between these 3 tools and how we can combine them together and keep them separated to work efficiently. Are y'all ready to dive in? Yeah. Yes. Cool. Yay. Thanks. So we're going to go in order. First, what is a formatter? And yes, this is the thing where you can all chuckle about it, tabs versus spaces, Silicon Valley jokes. A formatter is a tool that reads in your source code and auto-formats it for you or complains about you not having done the right formatting. That's all it does. That's all a formatter should do, which is awesome. And I'll give you an example. This is valid JavaScript. It's very ugly. It's friend equals friend or me. If you were to pass this to a formatter such as Prettier, it might get auto-formatted to something like this, friend equals friend or me, but on the same line with correct spacing, maybe a semicolon if that's your deal. That's good. This is nice. And we like formatters, right? Because they do the work for us. They mean that we don't have to manually edit the tabs and or spaces. We don't have to futz around with the new lines. They do it for us quickly. Yay. Now, on the inside, a formatter works by converting your code to a format called AST, or Abstract Syntax Tree. This is a simplified version of that. And we're not going to need to memorize this. I'm not going to quiz you on what's an assignment expression or logical expression, whatever. But I want you to see that on the inside, this is how all the tools I'm going to talk about generally represent your code, give or take. We have type assignment expression, where the expression has left friend, operator equals, and right friend or me. This is what I work with every day, and now you're going to suffer with me. So that AST, again defining it, it's the format that static analysis tools read your source code into. And again, showing it, that's this thing. That's really cool and really useful. And I'm not going to dive too deep into it, but I want you to know that if you ever see a tool documentation thing online that mentions an AST, you don't have to be scared. You don't have to fear the linter. You don't have to FUD it up. It's just talking about how these tools think about your code. But what you really care about is the npm install commands. This is an example of just the very bare bones basic way of setting up Prettier. Has anyone done this exact set of scripts before? Just curious. Yeah, a few people. Yeah, you've done this. All right. You've installed Prettier as a dev dependency. I see my hyphens got combined together. Thanks, PowerPoint. And then you've done like npx prettier dot, so the current directory dash write, something like that. That's reasonable. Okay, there we go. Now, if you don't want to memorize that, I have all this stuff, all the things I'm going to go over today, available for you in this template TypeScript node package. And I really encourage you to use this or some other template that gives you auto-formatting, linting, and so on out of the box. Because we're going to go through exhaustively how to set up ESLint and TypeScript for React, as you might have guessed we will. And it's all reasonable stuff. No config file we see will be more than a dozen lines, but it's nice to have it done for you. And also, this means you don't have to like jot notes down or take pictures of the code slides. You can just copy them from there. Hooray! And I have a few more pro tips. One, use the VS Code or equivalent editor extension for Prettier. You can, in your repo, set VS Code/extensions.json, and then have a recommendation so that if someone new opens the repo, they'll be told, hey, you might want to install the Prettier extension. And then you can set your default formatter in VS Code to that Prettier extension and say that you can auto-format on save, which a lot of people don't do. And I see people manually typing in spaces to satisfy Prettier like it's 2005 or something. Ridiculous. So you can do it for you. Have it do it for you. Woo. I do this for accessibility because I'm told that people who use screen readers or other assistive technology such as that like tabs. But just fun fact, if you have any preferences, you can throw them in a .prettierrc.json file. Anyone gonna boo me or cheer me or yeah, whatever, shut up. Okay, we're clean. Yeah, accessibility, thank you. That's it, that's all that I'm gonna go over for formatting, specifically on how to format it. We're done, good. Let's actually talk about a linter though. That's the thing that really excites me. And no, we did not just cover a linter. A linter is not a formatter, more on that later. A linter is a tool that runs a set of checks on your source code. It runs a set of checks, things that actually look at the logic of your code and yell at you about it. And each of those checks is a discrete rule. A rule is a set of things that the code looks for, and it may optionally complain on if it sees your file violates it. And each of those complaints may optionally provide a way to fix for that rule. Each of those rules is discrete. It doesn't know about each other. So let's take a look at an example rule. Fun fact, the code I showed you earlier, friend equals friend or me, is actually not the cleanest way to represent that thing. If you had the ESLint rule, logical assignment operators, set to error rather than warn or off, those are the three options for ESLint rules, it would tell you, aha, you loser, that's just my internal monologue, you friends, assignment equals can be replaced with operator assignment. And then it would, in your editor, if you want, autofix it to friend or equals me. Did anyone know about this syntax? No? Look at that. That's so much cleaner. I like it. So smart. Look at you. Good stuff. So if you want these beautiful things done for you, you can npm install ESLint. My hyphen was correct this time. Say dev. You can npm init at ESLint/config, and that'll walk you through setting up an ESLint config. And then you can do npx ESLint dot. Now, fun fact about that dot. You've probably maybe seen it in tools and been like, why is there a dot in my bash script? Dot refers to the current directory. Thank you for nodding. I'm excited some people know this. So dot says to ESLint, I am providing you the path of a directory because that's what ESLint takes in, a list of files and or directory globs. So I'm just saying do the current directory, everything. Lint all my stuff. Now, if you don't want to go through the ESLint init, or if you just want to see how these things work from scratch, the first important part of an ESLint config I recommend is extending ESLint:recommended, which is the list of rules that the ESLint team has, through literally years of scrutinizing code, come to understand to be the things that most code bases probably want. So if you really want to configure rules, you can add a rules object, but like most of the time, you don't need to do this to start. Eventually, you may find that rules are not applicable to your code base, and you might want to set them to off, and that's okay. And I just want to emphasize this. It's okay to disable a lint rule in your code base. I've seen a lot of people say phrases like, I can't possibly deploy this code. The linter is yelling at me. No, just disable the rule and move on with your life. Amen. Now, if you want to get things set up for React, it is a little bit more complicated. There are 2 good ESLint plugins, so NPM packages that give you more lint rules that look at new and unique things. There's a nice little ESLint plugin for React, and then there's an additional one for React hooks, because back in the day, the hooks were not a part of React, or they were new. And also, fun fact, JSX is not natively JavaScript. Who knows if it ever will be. So you do need to configure the ESLint parser to understand JSX. By default, it says, no, that's not real. And then also, the plugins need to be enabled explicitly. You need to tell ESLint which plugins you're going to use so it can load them in. Lastly, those plugins, the React one, wants to know what React version you're using. It behaves a little differently in older React versions, so just tell it settings React version detect. Just look at my package JSON. And this is why a lot of people hate ESLint, because I just had to spend like a minute going over the lines. So again, please, copy and paste from a template. Don't feel the need to do this all yourself if you don't have the time. All right, so if you want to run that, you can do ESLint.npx ESLint. I recommend a couple little extra flags. One is report unused disable directives. Who here knows what a disable directive in ESLint is? Awesome, like as few people as possible is my preference. A disable directive is that little thing. It says, ESLint, you might complain on the next line, shut up about it. Don't yell at me about no console. Hi. Now, if you end up changing the line to like something that doesn't violate the rule, ESLint won't normally yell at you saying this ESLint disable is unnecessary. But if you enable report unused disable directives, then it will yell at you. Because why would you want to keep these comments around? These comments are ugly. I don't like that. So yeah, definitely recommend enabling that thing so you don't get the other thing. Also, fun fact, you can run ESLint with a -- fix command, so it'll auto-fix all the things that are wrong in your code base. Now, not all rules are auto-fixable, but most of the recommended ones, if possible, have a fixer. So that's useful. Fun fact, I added the ability to -- fix report unused disable directives. I'm very proud of that. My little ESLint contribution. Yay, open source, woo! Awesome, all right. And then one more thing is max warning 0. Because rules can be configured with one of 3 severities: off, warn, error. A warning is still going to yell at you, but it won't fail the build. It won't cause ESLint to exit with status code non-zero, which means that people will just be trained to ignore the warnings, to ignore ESLint, and we don't like that. So if possible, max warning 0 is good. Okay, and similar to Prettier, you can add a recommendation for installing ESLint in your repo. And you can also say in your code actions on save, source fix all ESLint, which enables fixing all your shenanigans that are wrong on save. So that's nice. I like this. This is how I do ESLint. And I've worked on some linter things, so you should probably at least put that opinion into consideration. Clean. Good. I don't have like a nice, clever segue for this. I just think it's cute. Okay. One more important thing about ESLint, and I want you to say it with me. 3, 2, 1. Stop using ESLint for formatting. Thank you. That was good. Stop using ESLint for formatting. That's not what it's for. Matting. This rule indents. The other rules, max lens, semi, whatever, they're evil. They are bad. Don't use ESLint for formatting. Please, for the love of all that is good. I have 13 minutes left, and 12 of them are just going to be me repeating the phrase. No. So there's not the same stuff going on. A linter is not a formatter. A formatter is a tool that reformats all in one pass. It's real fast. It's real clever. It's real nice. Props to the creator of Prettier at this conference. A linter runs a set of individual discrete rules that look at the logic of your code, which means it can actually handle discrete rules, individual pieces of logic that can be turned off and configured. But it's slower. And it has explicit logic for every edge case because it cares about those edge cases. So all the lint rules that do things like configure your indentation levels are incredibly buggy. We have a pinned issue on the TypeScript ESLint repo. I'll explain what that is later. Explaining to people why our indent rule is broken and we're not going to fix it. Do it yourself because we don't have the time for that crap. So this is us. Do not enable formatting rules, and especially don't ask us to fix them because they're not what a linter is for. Fundamentally, a linter is not for formatting. It's for linting, and a formatter is for formatting. I've already bored you. I'm moving on. Let's talk about something much more exciting, TypeScript. Who here uses TypeScript and loves it? Woo! Yes, buy my book. TypeScript, for those who did not raise your hand, that's reasonable too. If you haven't discovered it, it's a superset of JavaScript. That phrase means nothing to most people. JavaScript with types, otherwise known as, JavaScript describes only your code's values. You can say like let my value, but there's no standard way built into the JavaScript language yet to describe the types of your values, the intent behind them. I intend for this variable to only ever be a number. Oh, okay. That's what TypeScript gives you, along with a few other things. Yay, prettier. TypeScript is 4 things. TypeScript is a programming language that describes the existing JavaScript syntax, plus a bunch of new things for types, like that colon number we saw. That's just the idea of TypeScript, the vibe, the aesthetic. TypeScript also provides a type checker, which is a program that reads in your files and reports if you have like a likely issue. Like, oh, you said this will be a number, then you gave it a string, you're probably wrong. Go fix it. That's a program. On top of the type checker, we have the compiler, TSC, TypeScript compiler, that runs the type checker and also transpiles your code from the TypeScript syntax to the equivalent JavaScript or other things. And then lastly, we have the language service, which is the program that runs the type checker and or compiler inside an editor or IDE, such as VS Code. And this is a very important distinction, the delineation between these 4 things, because people get confused sometimes about what TypeScript is. It is all 4 of these, confusingly. Now, this is an example of why you might want TypeScript with React. Here we have a MyButton component. It's fine if you don't scrutinize this code too closely. There's probably a bug somewhere. And without TypeScript, there's really no way for us to know whether this break the internet component that renders MyButton is correct. Truly no way. Maybe that first thing, MyButton, is intended to be okay. OnClick equals nothing. Probably not, because why would you have a button that doesn't have an OnClick? I don't know if that's an accessibility issue. It's surely a usability one. Providing a string as OnClick is probably wrong. Actually, this third one is probably fine, but you had to read the code to know that. And then that last one, it's not OnClick or OnTap. It's one of them. TypeScript lets us know when these things are wrong. So if we were to change it from button.js to button.tsx, TypeScript would yell at us saying OnClick is missing. You said it should be there. Or you said OnTap instead of OnClick. Okay. Now, I will note in your TS configs, this is a configuration talk, that if you set compiler options.jsx to something, that is what lets TypeScript read in your JSX syntax. It won't natively. So if you're setting up a new TypeScript project and it doesn't understand your JSX code, do that thing. Now, there's also another thing called no implicit any. I'm expecting slightly less enthusiasm. Who here's enabled no implicit any? Yay, cool. By default, there's no way for TypeScript to know what the type of onClick is. It doesn't know if it's like a function or undefined or function with a particular parameter, whatever. So the no implicit any compiler option, which is disabled by default, unfortunately, is the thing that tells TypeScript to yell at us if it can't tell what type stuff is. So if we were to enable no implicit any, it would yell at onClick. And then if we were to do the right thing, which is like declare a props interface or type and say what onClick is, then it would know to yell at us about the onClick equals wat. Because finally, TypeScript knows wat is not a function. Yay, TypeScript. Cool. So if you want to get started with TypeScript, similar to before, install it, save dev, npx tsc -- init will give you like the nice default starter ts config, and then you can run the TypeScript compiler tsc. Now, if you want to go through from scratch, these are the 4 really nice compiler options for React I recommend. JSX, I'm not going to go into the different ways that code will handle JSX syntax, if it should output that syntax or the equivalent react.createElement or whatever. Module ESNext, so that TypeScript understands you're working in ESNext, and if it outputs code, it should use JavaScript modules, not .js. Strict true is an awesome compiler flag that enables no implicit any and others. Yeah. Thank you. And now target is an often confused one. When TypeScript wants to know what APIs are available, it has to be told what version of JavaScript you're using, because the APIs available in like Chrome 9001 are not the same as Internet Explorer -3. So target ES 2021 tells TypeScript, I will make available the APIs that are existing in ES 2021, that edition of JavaScript. All reasonable stuff so far, right? Let's make it more complicated. All right, so a few more compiler options, optional but good. ES module interop tells TypeScript to not be so nitpicky about checking whether you're import defaulting or whatever, like the way modules import. Force consistent casing in file names is a mouthful, but it does what you would think. If you have an import with the wrong casing, upper versus lower, it'll yell at you. Skip libcheck is a really cool little optimization. By default, TypeScript will type check your node modules. It'll let you know if there's a type error in your node modules, which is like a total waste of time for most projects. So this tells it to shut up about it and skip. Yay. Awesome. Now, ignore everything I just said. Frameworks will write the TS config for you. Next, Remix, Astro, they all do this for you. So as long as they are setting strict true and you're not turning it off, yes, good. Now, if you ever want to learn more, aka.ms/tsconfig. aka.ms is like the Microsoft Bitly because they didn't want to pay for Bitly, so they built it themselves. Also, it's like a really cute URL. This has all the compiler options documentation you could possibly want. Also, buy my book, I go over it. Now, again, not the same between two types of tools. TypeScript is not a linter. Don't say that TypeScript is linting your code. Don't say that ESLint is type checking your code. They're not the same. A linter is a thing that runs a set of discretely configurable rules, which makes it faster, but it only sees one file at a time. It's just looking at your syntax. Whereas TypeScript is looking not just at your syntax, but the types, understanding your program as a whole, kumbaya, which makes it much smarter, but much slower. Which brings up an interesting issue because I thought linters are awesome, but TypeScript is so much smarter than them. Oh no, I skipped slides, I'm sorry. I forgot about this one. So little pro tips about TypeScript. If you're running them with ESLint, ESLint.rules.customizations is a thing I added to the VS Code plugin for ESLint. I highly recommend setting your ESLint errors to all be listed as warnings in VS Code, even though they block the build as errors, because it's really confusing when both ESLint and TypeScript give you the same color squiggly, and you have like 3 errors from something not being undefined. This way, you can ambiguate or disambiguate. Red is TypeScript, yellow is VS Code's ESLint plugin. Who would have thought? And then also, TypeScript.tsdk tells TypeScript in VS Code to use your specific project's version because it might be different from your global installed VS Code version. Cool? Cool. Yeah. Awesome. Okay, cool. There we go. This is what I was starting on. Sorry. So TypeScript ESLint is the project that I work on that enables you to run ESLint code on TypeScript stuff. Now, this is because similar to JSX, TypeScript syntax is not JavaScript syntax. It's not the same. So we provide 2 major things, among others. We provide a parser, which tells ESLint how to read TypeScript syntax. And we provide an ESLint plugin, which is a bunch of ESLint rules, like that React one. So if you want to enable us, you can extend from our recommended rules, highly recommend, and then also use parser TypeScript ESLint parser. I'm going to speed up now because I'm slowly going over time. So just as an example, there's a fun little TypeScript syntax thing where if you have literal as literal, you can replace that, as this prefer as const rule would tell you, with as const, which is like a nice little syntax shortcut. So smart, look at you, good. But if only there was some way to use type information in our rules, because the linter doesn't understand type information. And if we did have type info, then we would have like this new 3rd category with like a type checked linter type thing. And that's why TypeScript ESLint is awesome, because we have a new category of lint rules, a new way to scream angrily about your code base. The list of lint rules we have includes a bunch of them that use type information. Without type info, there's no way for JavaScript linters to know that console.log does not return a venable, a promise. But our lint rule would yell at you and say, hey, you don't need to await that. That does nothing. It just makes your code a little slower. And it would auto-fix it for you to just console.log lat. Awesome. So just as a little bit more complex of an example to show that linters can actually find some pretty severe stuff in your code, here we have a button component that says running is a Boolean state. On click, we disable the button by setting that running state, await on click, and set running false. But similar to before, on click is a function that returns void. We don't need to await it. So if we were to use a linter, we'd get the complaints. And one way to fix it would be to change the types to say that it returns promise void. Or if we know it never returns promise void, we could just remove the awaits, which then would let us know that this state is like totally unnecessary. Like it's always going to be false. It's synchronously changing. So we could remove that, which then means the function can be removed, which means the state can be removed, which means the button is always disabled, which means using TypeScript ESLint, we just removed 1/3 of our code base. Yes! Dead code removed. Dead code is bad. Performance. Good. Okay. So I highly recommend, if you are in a TypeScript code base, don't only enable our recommended rules, enable recommended requiring type checking, and set parser options.project to true, which tells our tooling, the TypeScript ESLint tooling, to use your closest tsconfig to each file to generate type info for the file. And then all those awesome type check rules will start screaming at you. Yes, scream, punish me. Good. Awesome. And then this is, we can gloss over this. This is the combination of the React configuration with TypeScript ESLint. Again, this is stuff you can find online. Tweet at me if it's not available. Cool. So again, you can find all this stuff online. I have a nice repo set up, Linting TypeScript in 2023, that has like 3 even better examples of TypeScript ESLint finding issues and a little demo app. Awesome. So let's recap. We talked about static analysis. Don't FUD it up. Don't fear the linter. So proud of that one. We talked about what a formatter is. It just formats your code. We talked about what a linter is, a discrete set of rules. Stop using ESLint for formatting. Then, we talked about TypeScript and then adding TypeScript to ESLint. Very exciting stuff. If you want to get started with these things, if you haven't yet, no shame, it's okay. All these things have great SEO, so you can Google them or use these URLs. Good stuff. Also, I have a few recommended, really quick, simple next steps. Just try these out. 1, check your formatter configuration. See if it's super customized and weird. Make sure you're not using ESLint for formatting. 2, check your linter. See if you're enabling TypeScript ESLint config. Make sure your editor is using like smart settings, like the things I recommended. And if you happen to maintain a large framework, such as a full-stack react.js application framework that's used by like thousands upon thousands of developers, make sure that your recommended ESLint config does extend from the aforementioned library author recommended configs. Okay, also, please support us because we are an independent open source project and we have a current budget of about $30,000 each year, which is split across like 5 or 6 devs. We have an open collective. I work on that full time. I'm also a Microsoft MVP. I don't know what that means, but it seems to be good. I wrote a book on TypeScript, Learning TypeScript. Yay, it's a good book, I think. And then also I'm an independent open source maintainer myself, and I can only do the thing that I'm currently doing, evangelizing the tools, and then also working on them, thanks to sponsors on GitHub and similar. So please support me. Thank you very much. Have a great day.